Hi, welcome to brilliantmaths.com, where every student has an opportunity to excel in math. If you are still struggling with your maths, don't worry, just stay with us at brilliantmaths.com and you will surely improve. If you have not subscribed, subscribe to it. Today's lesson is from Brilliant Maths Module 3, Chapter 3. If you don't have a copy, subscribe to Brilliant Maths Module 3, ask for a copy, and it will be sent to you. Grab the copy and let's work together. Today's lesson is simultaneous equations. What do you mean by simultaneous? It means side by side. So we'll be solving two equations with two unknowns side by side. Example 1. Solve the equations 4x plus y is equal to 23, x plus y is equal to 8. There are two main methods. There's the elimination method and the substitution method. So we're going to start with the elimination method. Let's see how it works. To solve these equations using the elimination method, the target is to eliminate one of the unknowns, either the x or the y. So the first thing is to observe the equations. The first one is 4x plus y is equal to 23. And the second one is x plus y is equal to 8. Before you can eliminate, the coefficients of any of the unknowns have to be the same. Then you can add or subtract as the case may be. In this example, the coefficient of x in the first equation is 4. The coefficient of x in the second one is 1, so they are not the same. The coefficient of y is 1 in both equations. So we can eliminate y. Both of them are positive, so if we simply subtract, we can eliminate y. So we have 4x minus x is 3x. Y minus y is 0. So 3x is equal to 23 minus 8. And 23 minus 8 is 15. We can then solve for x. Therefore, x is equal to 15 over 3, which is equal to 5. So here we have found the value of x. The next step would then be to find the value of y. If x is 5, we substitute x equal to 5 in any of the equations. And I choose to do that to equation 2. X plus y is equal to 8. So 5 plus y is equal to 8. That implies that y is equal to 8 minus 5. So y is equal to 3. Let's check. If x is 5 and y is 3, x plus y is equal to 8. The answers are correct. Solving simultaneous equations, let's look at this example. Solve the equations 2x plus 5y is equal to 15 and 3x minus 2y is equal to 13 simultaneously using the elimination method. Remember that to use the elimination method, you need to eliminate one of the unknowns. And before you can do that, the coefficient of that particular unknown should be the same in both equations. But in this case, the coefficient of x is 2x in the first equation, and it's 3x in the second. So none of them is the same. The coefficient of y in the first one is 5y, and in the second one is minus 2y. But we can balance them out so that we'll be able to eliminate. So solution. We have 2x plus 5y is equal to 15. That's our equation 1. And 3x minus 2y is equal to 13. That's our equation 2. So when we have two equations in this form and we want to eliminate, I would like to eliminate the y. So to make both of them to have the same coefficient, I'll multiply equation 1 by 2 so that the coefficient of y becomes 10y. Then I'll multiply equation 2 by 5 so that the coefficient of y will also be 10. And in this case, one is positive and the other will be negative, so I can simply add. So equation 1 times 2 becomes 4x plus 10y is equal to 30. We can call this equation 3. And then the next one, 5 times equation 2 will give us 15x minus 10y is equal to 5 times 3 is 15, carry 1. 5 times 1 is 5, plus 1 is 6. And we call that equation 4. To be able to eliminate y, we add equation 3 and 4. So we have 4x plus 15x becomes 19x. 10y minus 10y becomes 0. So we eliminate the y because this is positive 10 and we're adding negative 10 to it, so it becomes 0. So y is eliminated. Then 30 plus 65 is 95. So 19x is equal to 95. So x is equal to 95 divided by 19, which is equal to 5. Because 19 times 5 is 95. Next, we have to find the value of y. We substitute this value of x into any of the equations. So I'll choose to substitute into equation 1. X is 5, so 2x plus 5y is equal to 15. So 2 times 5 plus 5y is equal to 15. That means that 5y is equal to 15 minus 10. So 5y is equal to 5 implies y is equal to 1. Because 5 divided by 5 will give us 1. So x is 5 and y is 1. Can we check to see if that will satisfy both equations? x 5, y 1. Let's check with equation 2. 3 times 5 is 15 minus 2 times 1, which is 2. 15 minus 2 will give us 13. So it satisfies equation 2. Also in equation 1, 2 times 5 is 10 plus 5 times 1 is 5. 10 plus 5 is 15. So x equal to 5 and y is equal to 1 satisfies both equations. So that's the correct answer. In this example, we want to solve simultaneously using the substitution method. Use the substitution method to solve the equation 3x plus y is equal to 9 and 5x minus y is equal to 7. X plus y is equal to 9. 5x minus y is equal to 7. Before you can substitute, this is our equation 1, and that's equation 2. Before you can substitute, you have to rearrange any of the equations and make one unknown the subject. This is what I mean. 3x plus y is equal to 9. I'll rearrange it to become y is equal to 9 minus 3x. This becomes our equation 3. We'll now substitute this equation into equation 2. That means that wherever we see y or find y in equation 2, we write it as 9 minus 3x. So 5x minus, instead of writing y, it becomes 9 minus 3x in a bracket is equal to 7. We can call this equation 4. All right. Let's solve now. 5x minus 9 plus 3x is equal to 7. Then we collect like terms. 5x plus 3x will give us 8x is equal to 7 plus 9, because 9 is crossing the equality, so it changes from minus to plus. 7 plus 9 is 16. And that means that x is equal to 16 over 8, which is equal to 2. So the value of x is 2. So now that we have a value for x, we will substitute that value into equation 1 or 2. I'll choose to substitute it into equation 1. So I have 5x minus y is equal to 7. So x is equal to 2. So 5 times 2 minus y is equal to 7. Y here is negative, so I'll move it to the other side, to the right-hand side of the equation, and bring 7 to the left. So I have 10 minus 7 is equal to y. So the value of y is 10 minus 7, which is 3. So let's check to see if x is actually 2 and y is 3. Do those two solutions satisfy the two equations? Let's check. If x is 2, 3 times 2 will be 6, plus y is 3. So we have 6 plus 3, which is equal to 9. So it satisfies the first equation. Let's check for the second one. X is 2. 5 times 2 is 10, and y is 3. 10 minus 3 is 7. So x is equal to 2 and y is equal to 3 satisfies both equations. In this example, we want to use the substitution method to solve these two equations simultaneously. And remember that to use the substitution method, you have to make one of the unknowns the subject. Let's work this out. Solution. The first equation is 10x minus y is equal to 3. So that's our equation 1. Then 3x plus 2y is equal to 17. That's equation 2. Let's make y the subject in equation 1. So we have 10x minus y is equal to 3. We'll need positive y, so let's take y to the right-hand side and bring 3 to the left. So we have 10x minus 3, and that's actually equal to y. So y is equal to 10x minus 3. We'll substitute this value of y into the second equation. So we are calling this our equation 3. So anywhere we find y in equation 2, we'll write 10x minus 3. So 3x plus 2y, our y becomes 10x minus 3 is equal to 17. We expand the bracket now. We have 3x plus 2 times 10x is 20x minus 2 times 3 is 6 is equal to 17. We collect like terms. 3x and 20x are like terms. So 3x plus 20x gives us 23x is equal to 17. We take minus 6 from the left-hand side of the equation to the right-hand side, and it becomes positive. 17 plus 6. And 17 plus 6 is equal to 23. So 23x is equal to 23. So x is equal to 23 divided by 23, which is 1. So we have a value for x. The next step is to substitute that value into equation 1 or equation 2 to find the value of y. So we have, let's use equation 2 this time. 3x plus 2y is equal to 17. The value of x is 1. So 3 times 1 plus 2y is equal to 17. 2y is equal to 17 minus 3. And 17 minus 3 is 14. So 2y is equal to 14. So if 2y is equal to 14, what is the value of y? Y is equal to 14 divided by 2, which is equal to 7. So when you have found the two values, that is the value for x and the value for y, to check if your answer is correct, you substitute those values into the original equations. So let's see. X is 1. So 10 times x in equation 1 will be 10 minus y is 7. So 10 minus 7 is equal to 3. So those answers satisfy equation 1. Let's check for equation 2. X is 1. 3 times 1 is 3 plus y is 7. 2 times 7 is 14. And 14 plus 3 is 17. So x is equal to 1 and y is equal to 7 satisfies both equation 1 and 2. In this next example, we want to solve a word problem which involves simultaneous equations. Example, the difference between two numbers is 7. If their sum is 25, find the two numbers. We need to set up two equations with this information that we have and then solve them simultaneously. Let's see how that is done. Solution. I read the question again. The difference between two numbers is 7. So we say let the numbers be x and y. So the first step, let the numbers be x and y. So the first equation will be difference. That is take away. So we say x minus y is equal to 7. So that's our equation 1. Secondly, if their sum is 25, that means x plus y is equal to 25. That's the second equation. Do you see how easy it is to solve? X minus y is 7, and x plus y is 25. I'm going to use the elimination method to solve this. So that's equation 1 and equation 2. The coefficient of x in both equations is 1, and the coefficient of y in both is also 1. So I can choose to eliminate x or y. In this case, because y is negative in equation 1 and positive in equation 2, I would like to eliminate y by adding equation 1 and 2. So add 1 and 2. If I add 1 and 2, I have x plus x, that will give me 2x, minus y plus y will be 0. That eliminates y. 7 plus 25 is 32. So that means 2x is equal to 32. And if 2x is equal to 32, x is equal to 32 divided by 2, which is equal to 16. So we have that x is equal to 16. Let's substitute x equals 16 into equation 1. Equation 1 is x minus y is equal to 7. So x is 16, so 16 minus y is equal to 7. So what's the value of y? We collect like terms. 16 minus 7. So we'll bring 7 to the left-hand side of the equation and take minus y to the right-hand side. And it becomes y. So 16 minus 7 is equal to y. And what is 16 minus 7? It means y is equal to 9. We can now check to see if our answers are correct. X 16 and y 9. We'll start with equation 1. X is 16. 16 minus 9 is equal to 7. So that satisfies equation 1. And equation 2, 16 plus 9 is equal to 25. So those values satisfy both equation 1 and 2. So anytime you have word problems involving simultaneous equations, read the problems carefully, take it step by step. You must have enough information to construct two equations which can be solved simultaneously to find the required answers. Take your time and do it. It's very easy. Next, we want to learn how to change the subject of a formula. Change of subject simply means writing the formula in terms of a given unknown. So for example, in the first equation here, we have r is equal to ny minus 6. This formula has been written in terms of r, but we want to rewrite it in terms of n. So changing the subject of a formula is similar to solving an equation. So simply work carefully and in the correct order. Examples. Make n the subject of the following. R is equal to ny minus 6. We want n to be the subject of this formula. So we want to write n on its own, preferably on the left-hand side of the equation. We can still leave it on the right for a while because it's positive. So that's where we want it to be. And move minus 6 from the right to the left. So r minus plus 6 is equal to ny. Minus 6 changes to plus 6 as it crosses equality. At this point, we can now write ny on the left-hand side. So it becomes ny is equal to r plus 6. Both of them are the same. It doesn't make any difference. We want to take y, to detangle y from n. And n multiplies y. So to be able to do that, we divide by y. So we're going to divide both sides by y. So ny over y is equal to r plus 6 over y. So y cancels y, and n is equal to r plus 6 over y. Now we have changed the subject from r to n. In the next formula, we have h into y plus n is equal to a. Let's follow the same steps. In this, we need to expand. So we multiply. It becomes hy plus hn is equal to a. Remember, we're making n the subject, so we want n to stand alone on the left-hand side. And here we have positive n on the left-hand side, so we'll leave it there and send the hy to the right-hand side of the equation. So we have hn is equal to a minus hy. So to detangle h and n, we divide both sides by h. So hn over h is equal to a minus hy over h. So that cancels that. N is equal to a minus hy all over h. This can also be written as A over H minus HY over H, which you can actually leave as A over H minus Y. So the answer can be written as A minus HY all over H, or A over H minus Y. Let's look at this example together. Make Y the subject of the formula B is equal to A plus D over Y squared. That means we want to rewrite this formula in terms of Y. It is written in terms of B, but we want to rewrite it in terms of Y. So the first step will be to multiply through by Y squared to eliminate the denominator. So solution. We have B is equal to A plus D over Y squared. So multiply each term by Y squared. So we have B Y squared is equal to A Y squared plus D Y squared over Y squared. So this cancels out, and we eliminate Y squared from that denominator. So now we have BY squared is equal to AY squared plus D. The target is to make Y the subject. So we collect every term that has Y in it. So BY squared minus AY squared is equal to D. Factorize the Y squared. We have Y squared into B minus A is equal to D. So Y squared is equal to D divided by B minus A. Detangle B minus A from Y squared because we are writing the formula in terms of Y. We have Y squared B minus A over B minus A is equal to D over B minus A. So that cancels out. And then Y squared is equal to D over B minus A. Y squared is equal to D over B minus A. We are writing the formula in terms of Y and not Y squared. So how do we remove this square from Y? You do the reverse operation. The reverse of squaring is finding the square root. So we'll find the square root of both sides. So if you find the square root of Y squared, you also find the square root of D over B minus A. So if you find the square root of Y squared, you get Y. So Y is equal to square root D over B minus A. Having done that, most students find this a little bit confusing. So let's just go over it again. We want to make Y the subject of this formula. B is equal to A plus D over Y squared. So the first step is to eliminate the Y from the denominator. And to do that, you multiply each term by Y squared, so it cancels out from under the D. By doing Y squared times B is BY squared, Y squared times A is AY squared, and D over Y squared times Y squared gives us D. So we have that. Remember, we're making Y the subject. So you collect all the Y's together. We have BY squared minus AY squared is equal to D. So you factorize the Y squared, and that gives you Y squared into B minus A is equal to D. So next, we want Y squared to stand on its own. So we divide both sides by B minus A. So we now have Y squared is equal to D over B minus A. Remember, we're making Y the subject and not Y squared. So how do we take away this square? We find the square root of both sides. The square root of y squared will give us y, and then it becomes the square root of d over b minus a. This lesson can be found in Brilliant Maths Module 3, Chapter 3. Grab a copy and let's work. We have more examples and more exercises there. BrilliantMaths.com. Subscribe and get access to all our resources. And always remember, the maths is fun and you can do it. Stay with us at Brilliant Maths and you will surely improve.